So I just wanted to give a run through of a workflow I've been using to stack and process some images I took recently of the Andromeda Galaxy. I started searching or trying to find such a workflow using Astro Pixel Processor and StarTools, as quite frankly my image editing skills with the likes of Gimp or Photoshop are non-existent, even after trying to follow several online videos. So I'll be using Astro Pixel Processor, which is an application that allows for the full processing of deep sky images. However, today I will use APP to initially stack the images before continuing the flow and image processing within StarTools. Sound complicated? Well, hopefully this video will show it's not too difficult to actually understand. Although APP is very powerful when it comes to it, it does have a lot of parameters, options, drop downs and choices, etc. and it can cause confusion. So hopefully in this video I'll show a simplistic workflow to stack the Andromeda images. The importance here is to make sure that the resultant data set from APP is as pure as possible without any optimizations or adjusting that APP would typically make. This non-adjusted data set is what StarTools needs to shine in what it can do. So for the first part of the video, I'll show you which features to turn off within APP and demonstrate how to process the raw images along with collaboration frames. The second part of the video, I'll walk through how to process the output image from APP using StarTools. And although it took me a bit of time to work out the best workflow and method, which seems to slightly change depending on which actual deep sky object we have imaged. But hopefully in the future, I can create some videos based on the workflows specific for other objects. Right, so let's get APP open and get started. Okay, so let's start APP. And the first thing we want to do, or it asks us to do, is set our working directory. So this is the folder where you probably have all of your light frames already. And it's also the folder where APP will output any of the files that it creates. So I'm just going to go into my folder working copy, which I've already set up. Just click open. It actually doesn't open anything. It just makes that the working directory. Now, on the left-hand side, just a quick overview, there's normally 0 to 6 and then it jumps to 9 sections that you simply just work through in order, and you would select various options as and when you get to them. However, today, as I mentioned, we're just going to go for the minimum, so we'll get a nice clean data set. On the right hand side of APP, this is where you would do your further image processing, such as stretching it, adjusting the colors or the levels, the saturations, etc., etc. But all of this today we'll be doing in StarTools instead. So the first thing you can also set in APP within the configuration file is just how much RAM the APP will use. So I've got 16 gig of RAM. However, for today I'm just setting this to 10, and hopefully by increasing it, it does make APP work a little bit quicker. So first box on the left, 0. So remember, this is just to get the best data set without any stretching or manipulating of the image. And for this one, we're just going to make sure that the algorithm is set to adaptive. So you can always, with APP, hover over, and it'll give you a wall of text if you want to read a little bit further. However, in this instance, adaptive is the option we want to choose. Everything else we leave as is. So the load tab, this is where we actually name the object. So M31, which is what the files will be tagged with later. And we're going to open our light frames. So you can see it's taken us to the working directory already. Just need to select and highlight all of the images and it'll load them up. So just to mention, the images I'm working with is 60 frames at a 60-second exposure each under an ISO 1600, and these were taken off a Canon DSLR camera. We don't need to assign the frames to any particular channel. We're not using or separating colors or channels out. So just click OK as is. And we are not processing frames from multiple sessions, such if you were doing a mosaic or an object over multiple nights or sessions. So again, on this one, we just hit OK. And processing and loading our light frames. So you can see at the bottom here, it's already picked all of them up. Hasn't actually done anything with them. It's just acknowledged that they are loaded into APP. Next set of files that we're going to pick up is our flat files. So for this, I just need to go to a different folder where I have them stored. Same ISO, same exposure time. Same again, just OK and OK. We've just got the one session. And you can see there for clarification, we've got 60 light frames, 100 flat frames. I'm going to open the dark frames next. Actually, while I'm here, I'll do the dark flats rather than jumping around. So again, just go to your folder, select them all, OK, OK. And then finally the darks. Which are important that they have the same temperature, the same settings, etc., that the lights were taken as well. So we'll add those in. The one thing APP does allow you to do, if you've already got a master, flat, dark, etc. file, you can load them straight in, and that saves a little bit of time when processing and integrating the files together. However, I just wanted to show you this from the beginning, so I've added them in separately. Okay, so leave everything else as is. We move on to tab 2, which is Calibrate. And in this tab, we want to scroll down and make sure that adaptive pedestal reduce amp glow is unticked. Okay, so that's a little bit of processing that APP could do against dark frame calibration. However, in this instance, we don't want it checked, so I've unchecked that. Tab 3, analyzing the stars, we leave as is. Tab 4, the registering of the files and the images, we leave as is. Number 5, the normalize, we do not want to neutralize the background. Okay, so again, that's part of the image processing, which we do not want APP to do in this instance. Okay, so everything else on there, we leave as is, just untick neutralize background. Number 6 is the actual integration. So what I'm just going to do here is reduce the lights down to about 94–95%. So at least when it's looking through the quality of the files or the light frames, it'll hopefully take the worst images out of there. Although I've already manually looked through for any perhaps satellites, aeroplanes, small bits of cloud, etc., etc. But in this instance, I just want APP to take what it believes is the top 94–95% frames and process those. Okay, so everything else we leave as is in there. And then all we need to do is at the very bottom of integrate, or tab 6, is press the actual integrate button itself. and APP will go away and do its magic. So it's just clarifying here the object name M31, so I'm happy with that. It doesn't actually influence any of the processing. It just allows APP to place a file name against the actual output or the end results. So APP is now starting to do all the calculations, making the master files, etc., etc. So I've got 60 light frames here, and some of the calibration files or about 100 per set. So this will take approximately 20 minutes to complete. So we'll let it do its work and come back and see what the output is. Okay, so that took just over 20 minutes, and what we can see here is the output from the process. So on the bottom, we can see that we've had a bad pixel map, master flat, master dark, and a master dark flat file all created, which if you double click on, it loads up into the main viewer. But the one that we are particularly interested in is the very bottom one, the RGB session _1. So double click on that. That's what it looks like. On the right hand side here, we can click an artificial stretch and an artificial neutralize background, and that is what APP would create for us without any adjustments. So it looks pretty good. A few areas of banding. We've got kind of like a bit of light pollution on the right hand side, as opposed to very dark on the bottom left hand side. But overall, for simple stacking, it's quite a good output. So these checkboxes on the right hand side, they are not actually saving to the file yet. They are just showing us what it could look like. And then if we click save, but we won't, the save on the right hand side, if we have stretch checked, it actually saves the stretched image. If we have it unchecked, it would save the image without being stretched. However, we don't need to save an actual file, because this session 1 fits file is what we need. It's already been created. And we're going to jump over now to StarTools and take a look what that application can do. So just start up StarTools. Okay, so first thing we need to do in the top left hand corner is we're going to open our output file from APP. I'm just going to browse to my folder. Just 1 second. Working copy, and there you go. So there's the one today that was created after the processing. So double click on it. Just give it a second to think about it. Okay, so this question, StarTools needs to know what type of data set it is. So therefore it understands whether the image or file has been stretched or balanced or has had nothing done to it. So we're going to select this middle option here, and also specifically indicate that's from a DSLR, which it was. And this basically just sets up StarTools knowing what type of information to look for. So it's indicated here that there's possible stacking artifacts, which is probably correct, seeing as we've just stacked the image in APP. And in a minute or two, we'll see how we can kind of crop, I suppose, the edge artifacts out. So press OK, and compared to APP, we are dark image, no processing is taking place, which is exactly what we wanted to bring into StarTools. And what we're going to do on the left-hand side here, There's some suggested different workflows starting from the top to the bottom. However, I'm going to go through the workflow that I used specifically for the Andromeda Galaxy. So auto develop, just going to click on that. And this is basically StarTools stretching the data, so stretching the image out, and just allows us to kind of see, as I said before, what a bit of a dark area here compared to the top right, where maybe a bit of light pollution or light seeped in. And then on the top left-hand corner, you can see a few artifacts there just from the stacking procedure. So for this point, we're not actually going to adjust anything. This is just a basic stretch, allowing us to see where the issue areas are, which we'll take care of in the next few steps. So we're going to keep that stretch, and it returns us to the home screen. And you can see what's happened here is at the top corner, track has turned green, which means that StarTools is actually tracking or creating a log of any adjustments that we are making. So later on, if you wanted to, you could go back several steps to undo and reprocess if you wanted to. Okay, so if we look here, we've got a resolution of 4000 by 2000, so quite a high resolution for 4300, sorry, by 2800. Way too high for what I really require. So I'm going to open the bin module, and we can zoom out here just to see we've still got the full image. And what the bin module allows us to do is it allows us to control or trade off the resolution, but increasing the detail and also reducing the noise. So even if we just went with the default 50%, you can see the image size is going to drop down to 2100 by 1400. But we're going to get a scale, the noise ratio of 50%, which is quite good. I'm going to drop it down a little bit more to 45%. And overall, the scales dropped down by 47%, but the noise reduction has changed by 452%, if I'm reading that correctly. So that sounds a good trade-off for me. So we're going to hit the keep button, and this will run the bin and adjustments and returns back to the home screen. And now obviously we want to try and get rid of these edges, as you can see all the way down here, if I zoom in a little bit more. On the very left-hand side, and I think it was at the top of the image. There, you can see this is like stacking artifacts, which we want to crop out. So just to zoom back out there, and we'll go to crop. And this is a simple case of dragging the area that we want to keep. Okay, so start again, sorry. Just to make sure I've got the right area. Okay, so you can kind of see there for case of framing, I've put the crosshairs ended up in the middle of the core, which is good, which is a little bit by chance. But we can either re-drag, or we can use the sliders at the bottom just by clicking. And just to, I guess, show the case in point, this is adjusting the X coordinates of where it's starting. To crop, I'm just going to go out a little bit more. And I don't think we want to be as far out on the right-hand side. So I'm just going to reduce that a little. And then the Y coordinate, just pull that down just a little bit. And at the bottom, increasing there. So you can drag manually if you want, or you can fine tune using the bars at the bottom. So that looks pretty good. So let's keep that. And then before we go on any further, I'm just going to rotate the image 180 degrees at the top and keep that. Okay, so The image is still mono or black and white, well, not black and white, grayscale, I suppose, but we'll adjust that later with colors. But for the minute, we want to try and get rid of these kind of gradients that we see going from light to dark, from the bottom left to the top right here. So this is where we use the wipe module, which is one of StarTools' I guess, magic or pretty impressive modules. And what we're going to do here is, I mean, in the actual instructions for this, these 4 different presets at the top, by clicking on them, will preset details along the bottom. However, what we're going to do, we're going to do the gradient, which is already selected. So that's the type of wipe we will be using. I'm going to set it to 6 pixels on the filter at the bottom. So what the filter does basically, if we click on the question mark, just to show you the help within here, it's how strong the wipe should be within the filter. So again, this is just over time, you know, adjusting things and trying things. However, for this image, I found 6 was a good value. And also, which you can't see, but on the other screen, it's also opened a specific help file to do with the wipe module. So we don't want to apply a wipe to the entire image because we would kind of take out a bit of the light, I suppose, from the core and from the galaxy itself. So we're going to mask the galaxy out. So click on mask at the top. I'm going to clear it because by default it just masks the entire image. And at the bottom here, so I've just cleared the mask at the bottom here. I'm going to choose lasso for the type of mask or the type of tool or brush I want to create. And all we're going to do here is hold down the mouse button, and hopefully you can see a green line that I am drawing approximately around the galaxy itself. Okay, so it's a little bit difficult because obviously it's not in color, but you should just be able to make out enough of the grayscale to see where the galaxy is. So let's have a look at that. Okay. Do that once more, I think, just to get a bit more of the shape around the edge, around the top, and back down the side. So we don't want to go right into the galaxy. We want to try and keep on the edges where the dust lanes are, around the corner. And when we release it, it'll contact. Okay, so that's not too bad. So what we want to do is invert it, because the green area of the mask is where the processing will take place, and the non-green is where the processing will not take place. So we'll press keep. This is because we want to keep the mask that we've created. We've got all the settings correct. So all we do is press do, and that reprocesses or re-renders the image based on the mask and based on the gradient and based on the anomaly filter that was set at the bottom. Okay, so there we go. So you can see around the edges, it's darkened everything up. It's nicely kept the dust lanes in the middle there, a little bit too far, and darkened the rest of the background up. So we could play around a little bit more with that, with the wipes, you know, a little bit more white area, I suppose, on the bottom right-hand corner here. But hopefully you get the idea of creating a mask around what we do or we don't want to be adjusted. And then pressing the do, that re-renders it. And then clicking on the before on the top right-hand corner. This is where we were before we used the wipe. And this is where we are after the wipe. Okay. So we'll keep that. Okay, press the keep button. We'll do it a second time. And we'll return back to the original page. So now that we've, I guess, you know, wiped the bad data out, what we can do is we can restretch the image. So this time I'm going to manually restretch the image instead of an automatic one. Whether you do manual develop or auto develop, you get this question. We're going to select redo a global stretch. And because we're doing it manually, what we get control of here is this top one that says digital development. Now, if I move this up to, let's try 88, 90%, you can see it looks quite good, as opposed to if we drop it all the way back down, it's still quite faint. So what I found with StarTools is, yes, you can read the instructions or the help files, etc. But by clicking, the minimum or clicking the maximum of a bar or an attribute, that's where I've found, oh yeah, visually this is what effects or what changes it will bring. So this one, let's go just a little bit higher. Okay, yeah, let's try about that, 91%. I think that's got enough of the galaxy itself, the dust lanes, etc., the dust rings, while keeping the background nice and dark as well. Okay, so we're going to keep this. And okay, we are going to move on to the next module now, which is HDR, High Dynamic Range. And this allows us to bring out the detail or the hidden detail that's in the data. So StarTools has, again, a few more initial defaults at the top. We're going to use Reveal Core. So by clicking that, it sets the parameters at the bottom for us. We're going to increase the detail size range. So this is pulling even more detail out. And then we're just going to increase the strength to about 2.2. And this is just, well, as it says, the actual strength of the module itself, or the optimization itself that's doing. Sometimes this one's slow, sometimes it's quick. So on the bottom right-hand corner there, you can just see a little circle ticking around while it's processing. Still going. This is obviously quite a intense process. Okay, so this one's finished, and we can click on the before, and we can click on the after. There's a few little areas, if we zoom in a little bit, that's managed to bring out. So there's the after the process, and if we click on, there's the before the process. And if you look at the core itself, previously it was a large, I guess, strong light. And if we click on the after, we can see that's reduced down slightly. So it's brought more detail out as opposed to just solid core. Okay, so like everything else, we'll keep the image. And we'll move on to the next module in the workflow. Okay, so the next one is life. And what this does, it kind of remodels the light diffraction within the stars. And it basically, let's see, where are we? Okay. Basically, it kind of adjusts the lights and the stars, I suppose, in the background. And it gives them a little bit more, I don't know how to describe it, life, I suppose, adjusting the colors. But for this, do we need a mask on this one? Yes, we do need a mask. But yeah, so it basically pushes back a busy star field. So you might think you've got too many stars in your image, and you can use this to kind of push some of those into the background. So the best way, obviously, is just to show you that happening. So we need a mask for this. We are going to go to mask, clear it, and we want to apply a mask to the entire image. So we just click on invert, and that gives us a green mask right across the image. So like the other modules, we'll click isolate is what we're going to go for at the top, and that sets the parameters around the bottom. And we're going to just decrease the strength, not too much, but at least we get an idea of what it does. And then click on do, and that re-renders the image, applying all of the settings for the module. So it's just doing its calculations, doing its thing. So the idea here is we've got quite a few stars in the main field, and this should push them back a little bit while keeping the size of the remaining stars. Okay, so if we zoom in a little bit and we can see the before, so you can see quite a few fainter stars, and then after it's reduced them without changing the size of the remaining stars. Okay, so let's just keep that, and we'll move on to the actual coloring. So color module. Now, just do a before and after. Okay, so this is how it looks right now. And one nice little feature I like is this max RGB. So rather than trying to eyeball the colors, if we put max RGB on and zoom in a little bit, we can see the RGB makeup of the actual image. And what I've found here is if we reduce the green, so I'm just going to increase the green bias reduce, and slowly you should see less green coming into the image being replaced by red. So I'm going to take that one down, take a little bit of the red out, okay, and then back. So I'm just tweaking this slightly, so there's a kind of a balance between blue and red with green removed. I don't think there's too much green in that area of space, so we'll reduce that. Return back to normal, and there's our image so far. Increase the dark saturation, so that brings a little bit more color in the darker areas. Increase that a little bit more, and we've got our before image, which is pretty much mono grayscale, and then we've got our after image, nice colors on the stars, around the bands, around the rings. It's not too bad, so you can keep tweaking that to get the colors that you like. As I said, max RGB, that's a pretty good tool to try and show you don't want too much green within the image. Okay, so looks a little bit out of focus. but for the time being, we will keep the colours. And what we're going to do here is kind of try and tidy up the rings around it by removing the grain. Okay, so we'll get less of a grainy effect and more of a smooth band. So to do this, we need to remove track, and we're going to go to noise grain reduction, which automatically appears, and we're going to do grain removal. And I don't want too much strength on this, we'll increase it just slightly. You can always adjust this again in the next stage. So this is going to denoise the whole image, which, as I say, smooths things out and does wonders for the black background, which we'll see in a second. So again, it's just doing its calculations, which a lot of StarTools modules are based on. Okay, so if we do a before and zoom in a little bit, so we'll be able to see what it's actually done. So there's our before, and if we click on our after, it's kind of smoothed everything out a little bit more. So it's a little less blotchy and patchy if I zoom in again. So this is our before, this is our after. So it smoothed everything out. Again, you can change the main one here as the grain dispersion. If we go too much, it probably over smooths it, and then if we go all the way down, you can see the patches again. If we go to, I think it was 9.2 it was on. So it's just a case of playing around with these settings or this setting until you get an image that you're happy with. Okay, so we're going to keep that. So that's looking quite good at the minute. Maybe you could have done a little bit more colour around here, but it's got a nice brown area in the dust trails. Core's a little bit sharp. Again, we could have adjusted that within the colours. So the last thing I want to show you is how to shrink the stars. So the stars requires a star mask, and to do that, rather than a mask for the full image, go to mask, clear the current mask, and then we want to go auto, select the stars, and click on do, and it'll create a mask automatically around the stars. Okay, so remember that the green mask are the areas that it will do its processing on. Click on do because we want to use that mask. And if I zoom out a little bit, and then we can adjust with the iterations at the bottom here. So the more iterations it goes through, the more and more stars, the more it will shrink the existing stars. So that's quite sparse on stars because they've been shrunk. If I go back to 1, you'll see they reappear again. So again, this is just a case of, you know, what you feel best or what looks best for yourself. Okay, so we're just going to, let's say, remain that on iteration 2. And I think I'm just going to clear the mask. Clear, keep. And I think that's probably our image done for the time being. So about 30 minutes or so, you can kind of see a little workflow that I've been through. As I say, you know, might want to tweak this color a little bit more, or when I go through again, spend more time trying to get the core not too burnt out. But the final thing to do is we just hit save, call it what you want, save it where you want, click on save, and we are done. So hopefully you understood the workflow. Not too much difficulty in getting through that. And the main thing with StarTools I find is just trying the different modules for different objects. And once you go into a parameter, set it low, set it high, and then you can see the differences that that module is actually doing or creating. Okay, so hopefully in the future I'll do some further walkthroughs for different objects using StarTools as well. But until then, thank you for watching, and I hope this helped out a little bit with your own image processing. Thank you.